Hello, my name is Thayer Altman, and I will be giving a presentation on PlaceAvoider, which is a software designed to steer first-person camera away from sensitive spaces. PlaceAvoider, steering first-person cameras away from sensitive spaces, was authored by Robert Templeman, Mohammed Hourayem, David Crandall, and Apu Kapadia. The subject of this paper comes on the heels of many wearable camera-containing smart devices, such as Google Glass or even the smartphone in your pocket. The goal of these devices is to capture everyday life and present it to a larger audience. The goal of PlaceAvoider is to intelligently filter those images captured by the smart device and prevent sensitive photos from being accessed by applications, legitimate or otherwise. Much of PlaceAvoider's technology utilizes computer vision and machine learning techniques. PlaceAvoider will sit at the operating system level such that images are intercepted before they get to the application. In addition to preventing accidental publishing of images, it will prevent a malicious application from apprehending the images. From a user perspective, PlaceAvoider first requires that each room in the location in question, such as a home or business, is enrolled in the software. This means taking multiple pictures of different angles, positions, and in different lighting conditions in each room. Then, each room is assigned a particular privacy policy. These policies, for instance, could be to do nothing with the image, delete the image if it's in this particular room, or mark the image for later review by the user to determine what to do with the image. Then, once the software is actually used, each image will be processed and a room will be assigned for that given image, and that policy will be applied to said image. PlaceAvoider uses learned images and additional contextual information such as GPS location and previous image in the stream to determine which room that image belongs to. There are two main modes that PlaceAvoider will be used, either closed or open locales. A closed locale is a situation where PlaceAvoider has learned and knows all rooms in question, such as a home. Open locale is used for places where PlaceAvoider only knows certain rooms and has policies for those rooms. But there are also rooms within the location that PlaceAvoider is not familiar with, such as a shared office. When images are initially enrolled with PlaceAvoider, the following methods are used to create a collection of features for each room. These features then become the fingerprint for the room. Each incoming image has these methods applied to it, and whichever room that image is most similar to is the room chosen for the given image. The methods listed here are fairly technical, but the basic gist is to create a list of identifying features that are specific to that room and that room only. As an example, the main type of determination used for closed locale is SIFT, or Scale Invariant Feature Transform. In summary, SIFT will find corners and other points within an image that are likely to withstand transformations, like different angles of image of capture, and so on. Then, a 128-dimensional vector is created for each point, and that becomes a blueprint of the room. So each vector would be a feature or a SIFT feature for that room. The scoring function shown here will return a score for the given image I against all enrolled images and their associated set of features. For the given image, the different features would be extracted. Then a ratio of the closeness of each feature of that image to one room's set of features over all other features in the room will be calculated. If that ratio is determined to be greater than a given threshold, it is then counted as matching one feature in this room's set of features. Then, for each feature from the image, if greater than the threshold, it will be counted as closely matching a feature from that room. For each room, the image will get a score, which is the sum of the closest matching features. Then, the room with the highest score becomes the room chosen for that given image. The tests conducted by the 4 researchers were done in a closed locale setup in 5 different locations. 3 to 5 rounds of enrollment of each room for each location was done as an initial setup. Then, each researcher wore a smartphone device from a lanyard around their neck set to take pictures every 3 seconds. This was meant to simulate wearing a device like Google Glass, which was not yet available to the researchers. The smartphones used were an iPhone 4S, iPhone 5, HTC Amaze, and Motorola Evo. The duration of the collection lasted between 15 minutes and 1 hour for each location. During the collection, each researcher simulated various daily chores in an attempt to get the best real-world use case of PlaceAvoider. As an example, in House 1, the author simulated activities like visiting the bathroom, working in the study, reading, and general household chores. The results of their study are shown here. In this dataset, it was a closed locale example with the number of rooms n equal to 5 for each dataset. So each dataset contained 5 rooms that were correctly enrolled with PlaceAvoider. So for each given image, it would have to fall into one of these 5 rooms per location. The baseline accuracies are shown for comparison purposes. They were calculated by each image being put into a room that had the highest number of matching features, or highest class. In this example, we see House 1 and House 3 having very high classification accuracy. This makes sense since each room would have a large number of features that would distinguish itself from the other rooms. As shown here, House 1 and House 3 are well organized or cluttered rooms, and therefore would have a large number of identifying features. Whereas House 2 is sparsely furnished and therefore would have a high degree of feature match from room to room, leading to the low classification accuracy. Results shown here are the same dataset of images, but each image downscaled to 1 megapixel. This was done to show the effect of resolution on PlaceAvoider's effectiveness and overall accuracy. As shown here, the performance was equal to or greater than that of the originally sized images. This is surprising since downsampling the image resulted in less SIFT features and therefore less total information to work with to distinguish the image from room to another room. This suggests that the limiting factor on PlaceAvoider's effectiveness may lie with the quality of the image and not specifically the resolution. Shown here are example images and whether they were correctly or incorrectly classified. The researchers speculate that the cause of the misclassifications might be caused by images including doors or windows and therefore showing features that may exist in other enrolled rooms or of the outside world in general. These features would then cause the classifier's confidence to be reduced and therefore give a higher likelihood of misclassification. As an example, the bottom row, second from the right, shows a doorway to another enrolled room. This may have attributed to the inaccuracy since the features detected through the doorway would match another room and cause the classifier to have mixed results. In addition to that, the image itself is quite blurry, which would lend itself to a potential misclassification in general, since the SIFT algorithm seeks to use sharp corners to classify the image with its given features. PlaceAvoider is a proof of concept, and therefore performance was not at the forefront of the researchers' intent. It was implemented on a multi-purpose workstation using unoptimized C++ code as well as MATLAB, Python, and R code. For each given image, it takes an average of 18.421 seconds to process the image. And this is done on a 2.6 gigahertz Xeon server. As proposed, the researchers intended for PlaceAvoider to be implemented either in a cloud-based application or on device. Given the performance results shown here, an on-device solution is not viable based on the processing time for each image. The researchers have reason to believe rewriting all code in C++ would give greater performance. Additionally, algorithmic optimizations were proposed and evaluated. It was found that a random subsampling of the SIFT descriptors resulted in the best accuracy while still reducing the overall algorithmic runtime. PlaceAvoider represents a working solution to protect an individual's privacy while still being able to capture day-to-day images and presenting them to a greater audience. PlaceAvoider's accuracy is reasonable enough for some implementations, but would still need work for others. When this work was initially done, Google Glass was in its infancy. And with the expectation of that technology becoming commonplace, the researchers attempted to create a solution that would deal with the privacy concerns of wearing a wearable smart device camera containing device at all times. Thank you.